Well, here we have the addition rule for probability. The first example is going to use playing cards. So I've got the pictures of the playing cards up and ready to go. So draw a card out of these 52. Find the probability that you get a jack or a 7. The or is a key word saying that we're going to be adding the two together. So for a jack or a 7, so for jacks, over here, there are 4 jacks, so that's 4 out of 52. Could also be a 7, and over here there's 4 sevens, so there's the 4 sevens. So that's 8 out of 52 total, or 15.4%. Then this section basically has two main examples. Here's one where the two things are distinct. A card could be a jack, or it could be a 7, but there is no such thing as the jack of sevens. So in that case, you just add the two fractions together, you're done. Next is one where it's possible that the two things could happen. So red cards, so that's all these bottom cards down here. That's half of the deck, 26. Then the queens, there's 4 queens. But when I say there's 26 red cards and there's 4 queens, if I were to stop right there, then these 2 red queens just got counted twice. So then what I need to do is right here, subtract the 2 red queens that got double counted. So in total, that's 28 out of 52, or if you divide that, multiply by 100, 53.8%. So there's those two main cases. One is like the first, the jack of sevens. There is no such thing as a jack of sevens. So the two cases are completely separate from each other. It's called mutually exclusive. So this would be the jacks. Here's the sevens. There's nowhere where they overlap where they're both jack of sevens. So then you just do the probability for each one. The or turns to addition. If they're not mutually exclusive, there is the chance for overlap, like with the queens and the red cards. Then you do add the two fractions together, probability of A and probability of B, but then those that were both A's and B's, in other words, this overlap over here, they got double counted, so you need to subtract that part. So here's another example, not with playing cards, but here's a table where people were given the drug Lipitor, other people were given a placebo, and then some people experienced a headache and some people did not. So next, find a probability a person had a headache or they took a placebo. So again, the or means we're going to add them together, but it's possible that somebody both had a headache and they took the placebo. So here we have headache people. So headache people would be this 15 and 65, so that's 80 headache people. The placebo people, that's going to be these people, 65 plus 3. But then those people that had a headache and placebo, these 65, they just got double counted. So we would have the first 80 coming from the headache people, this row right here. Next is placebo, so that's this column, 68. But then the 65 got counted twice, so you need to subtract that off. And all of it's out of 100 because I added up the 4 squares and it added up to be 100, so they're all out of 100. So it turns out to be 83%. From the same table, find the probability a person had Lipitor with a headache. So I would pause right there and figure out what that means. Lipitor with a headache. So that's actually these 15 people. So that's the first one. Or they took the placebo, but they did not get a headache. So that's these, they took the placebo and did not get a headache. So that's these 3. So in this case, there is no overlap. These two are distinct. It's either these 15 people or these 3. So we just need to do the two separately. So the 15 out of 100, the 3 out of 100 makes 18 out of 100, or 18%. The next definition is the complement, which is another way to say the opposite. So if A lives in this white circle, then the complement of it is all the rest of the blue stuff, everything except A. And the probability of A is equal to 1 minus the probability of the complement. So for an easy example, suppose that A means that it's going to rain today. And suppose that there's a 5% chance that it's going to rain. Well, if there's a 5% chance that it's going to rain, then what's the probability that it doesn't rain? So 5% chance for rain, 95% chance for doesn't rain. And then the next example, go back to that table with the headache and the Lipitor. So what's the probability that it's not a headache? So let's see. This means headache, but a bar over it means not. It means the opposite. So the opposite of headache is no headache. So that's these 17 plus 3 people down at the bottom. They did not have a headache. So if it's 17 plus 3, then that's 20 out of 100. So with this, I was just trying to show there's 2 ways you can, like with number 4, directly find out what's the probability when it has the bar over it. Just do it directly like I did. Or you could use this formula. Sometimes we use one, sometimes we use the other. And then on to example number 5. Suppose that there's this box that's got 2 red marbles, 3 green, and 4 blue marbles. So you pick one. What's the probability that it's red or green? So is this the case where you have to do the overlap? In other words, could a marble be red-green or red and green? And according to the setup, no, it's either red or green. So you just have to say, well, red or green, that means you add those 2 together. The or means add. Red and green adds up to 5 marbles out of 9 total. So 5 out of 9. And then, what about blue or red opposite? So if you put the blue and the red together, that it could be blue or it could be red, that's 6. If it's the opposite, so that means that it's neither blue nor red, that leaves the green. And so if it's the green, then the chances are 3 out of the total of 9. So 3/9 is supposed to be the answer for that one. And that's the end of this section.